Hello guys, so welcome to MJ School of Mining and Geology. In today's session, we are going to be focusing on the magnetic declination, and on the very last end, we're going to be focusing on the magnetic bearing. Welcome back to the map work course. Um, Please don't forget to like, share, comment, and hit the notification button below so that you get notified once we upload new content. And if you're struggling and or you are enjoying this, please comment on the comment section to let us know how you are feeling. Please stay tuned. And so magnetic declination is basically the angle between the true north and the magnetic north. All right, this is the angle between the true north with which does not change and the magnetic north which keeps on moving. So always for the tip is to be able to draw the information of the magnetic declination supplied in the question paper, and then because a mental image will be of help with the calculations. Okay, so consider the following. Um, these are six tips that we're gonna go we're gonna tackle one by one. So we want to know what is meaning or mean magnetic declination, okay, in degrees and minutes, and in which direction is the magnetic declination, and in which year is the magnetic declination given, and what is the annual change, in what direction is the average year change, and for what year must the magnetic declination be calculated. So let's start with the first one, mean magnetic declination. So you're going to be looking at the map or data provided, then listen to what the examiner or whoever is saying. For example, saying that the mean magnetic declination is 20 degrees 15 minutes west. All right, this is mean magnetic declination. Right, this means that the compass needle, all right, on your or that pointer inside the compass points 20 degrees and 15 minutes west of the true north. So if we were to draw this, we know that the true north is always like this, all right, pointing upward, and then it means now this magnetic north or magnetic or the needle moved at least 20 degrees 15 minutes west. So we'll say we know that now we shall eat. So it means we were here. Okay, we were here, and then now we moved at least 20 degrees 15 minutes west. So we'll have something like that. All right, this will be your magnetic north. All right, then now this angle is what we call 20 degrees 15 minutes west. This will be your magnetic or your mean magnetic declination. Like I said, you need to draw this because visualization, it makes these things to be easier. And the second thing is the direction of declination. So if it says west, the compass needle is to the left of the true north. Like I said, this is now we shall eat. So obviously, so if it says west, it means you are to the left of the true north. But if it says east, you are to the right of the true north. So draw a simple diagram with a vertical line for a true north, what I showed you previously, or a TN, true north, and then a slanted line to the left or to the right. If it says, for example, west, you will say this. If it says east, you will say that. And then this will be your angle, all right? This will be towards you east, this will be towards you west, all right? Now, label the angle between them. So you'll see, for example, that one, we said is 20 minutes, or 20 degrees. We said is 20 degrees, 15 minutes. Year of declination, check the year mentioned. For example, given for the year, the magnetic declination might be given for the year 2015. So this tells us that when the declination was measured, the declination was measured in this year. So you check mean magnetic declination, and then you check the direction of the declination, whether it's in the west or east, and then you also check the year of declination, and of course the mean annual change. So this will show you how much the declination changes each year. So example, annual change is 2 minutes east, all right, 2 minutes towards the east, all right. So it means so every year that angle would move 2 minutes towards the east. That is every year, all right. Every year the declination would change 2 minutes towards the east, and the direction of change, of course, yes, we saw that it changes 2 minutes towards the east, all right. So direction of change. Imagine you're looking at a compass and a map. We know if this is your map, your map will always be having that true north. All right. But now your compass on the other hand will be having that needle. All right. True north is the direction on the map, is this one. The magnetic north is where your compass needle points, right? Your magnetic north is where the compass needle points. So the angle between them is called magnetic declination, as I've mentioned. So if it says east, the angle is getting smaller if it was west. So this is very important to note. It will get smaller if it was west, or larger if it was already in the east. All right. So this angle, if let's say this is your true north, this is your true north, all right. So if it says east, for example, like that, all right. So if it says east, the angle is getting smaller if it was west, all right. So example, if it was here, if it was west, and then the direction of change, it says east, it means this thing, it changed, and then until now somewhere here. Now can you see that now this angle is becoming smaller? But if it was already on the east side, then it will get bigger. Okay. So to elaborate that further, so magnetic north moves slowly every year. So the angle of declination changes. For example, we saw that change. For example, you can say 2 minutes east every year. So if declination is west, magnetic north is to the left. Right? Is to the left. We saw that if magnetic north would be, it would be this would be magnetic north, it would be west of the true north. So the angle gets smaller. All right. So if the angle change is east, if the angle changes towards the side, it means that magnetic north is moving closer to the true north. It means this thing, it was now here, it now is here, now here, now here, now here, for example. So it's moving closer and closer to the true north. But if the declination is east, if the declination is east, all right, magnetic north, it will be magnetic north, yes, magnetic north, it will be to the left, or not to the left, but to the right of the true north. This is our true north, this is its right. So if the change is east, okay, if the change is east, it means that magnetic north is moving further away from the true north. Then now you are moving further away from the true north, further away from the true north. Okay, because it was here, and then now, for example, until they align, until they pass, and they pass, and they pass. So it will be moving further away and further away, so that the angle now becomes bigger and bigger. Now, last tip, calculate for a year, for a new year. So let's say you need to calculate for 2025, for 2024, but for example, now I gave you 2025. So time difference, remember magnetic declination was calculated in 2015, but now we are in 2025. So we want to check the difference, all right, in years. So this is today, you minus with the day it was calculated. So now 10 years has passed. But now, every year, magnetic declination changed by 2 minutes, for example, towards the east. So we'll say 2 minutes times 10, then we'll say 20 minutes towards the east. This is this year. This will be this year. All right. So new declination. So if originally was 20 minutes, 15, 20 degrees, 15 minutes towards the west, you're gonna subtract you're gonna subtract the 20, then you can find this 19 minutes 55 19 degrees 55 minutes. But I'm gonna show you the difference between subtracting and adding. All right, I'm gonna show you shortly the difference between subtracting and adding. So for example, mean magnetic declination, it will be 20 minutes 20 degrees, sorry, 15 minutes towards the west. All right, and then for the given year, then the year that magnetic declination was calculated was in 2015. So mean annual change, it will be 2 minutes towards the east. So we just wanted to wrap this thing up. We just wanted to wrap this thing up. But like I said, I want to bring to your attention how these things are calculated. All right, but I'm gonna show you shortly how we come up with these subtractions and other things. All right, so as we are practicing these questions, so we've got this question which says that the mean magnetic declination is 23 degrees 53 minutes west of the true north, with the July year 2002. So the mean annual change is 6 minutes westward. All right, so calculate the magnetic declination for the year 2009. So remember, initially or previously we calculated the magnetic declination for 2025. So now we want for 2020 or 2009. Okay, so we are now in 2009. So it means we must first calculate the difference in year. So we'll say, well, we are now in 2009, but this magnetic declination was calculated in 2002. So we wanted the difference between these. So to the difference between 2009 and 2002, you'll agree with me that this will be 7 years. All right. So now, and then we want to calculate the total change now. All right, so because they gave us that the mean annual change, we were given that the mean annual change is 6 minute westward. All right, 6 minute westward. This would imply, or therefore, our total change. Then we'll say, therefore, our total change, it will equal to this multiplied by 7 years. All right, and 6 times 7, you will get 42 minutes westward. Okay, westward. Now, but now we now you can now either add or subtract from the magnetic declination. Okay, but I want to bring to your attention that if okay, sharp, when do we add? I want to bring to your attention. So we add, let me write it down. We add the total change. We add the total change if in this is in South Africa, we add the total change if the magnetic north is moving, if it's moving further west. Okay, so this would mean in the same direction, as the original declination. That's when you're gonna add, all right? But if it was the if the change is towards the east, then we're gonna okay, we subtract, all right, we subtract the total change, we subtract the total change, okay, we subtract the total change, all right. um if the magnetic north is moving further east, okay, if it's moving further east, so it means if the change is towards the east, then it must be subtracted, okay. But if it's towards the west, we are adding. All right. So what did they tell us now? They told us that it's westward. So what do we do? It means we're gonna add. All right. It means we're gonna add because now they told us that the change is towards the they told us that the change is towards the what do you call this? Is towards the it's toward the west. All right. So I hope this makes sense. So moving right on, then we're gonna say, well, okay, we already got our change, our or what you call the total change. Okay, that is the total distance. The magnetic north has moved over that time is 42. All right, westward. Now we start to adjust the magnetic declination. All right. So if we want to adjust the magnetic declination, we add, because it's towards the west, we must add the total change. All right. Because the magnetic north is moving further west. So it means we will say, well, initially we were having, remember, we want to adjust the magnetic declination. We will say, well, initially we were having 23 degrees, um, 53 um 53 is 23 degrees 53 minutes. All right, that's what we had initially. So we will say, well, okay, if we have this, how can we adjust it? All right, then we can say, well, let's add, all right, let's add this 42. So this thing, this 42 minutes is like we are having 0 degrees, but 42, no, sorry, 42 minutes, right? So it means now we said because it's westward, we're gonna put the add sign and then we do that. All right. So you'd agree with me that 23 degrees plus 20 plus 0 degrees, it will just give us 23 degrees. All right. And then 53 plus 42, 53 plus 42, it will give us 95 minutes towards the west. Oh, bless me. Sorry. Um, Towards the west. But what do we know? We want to tidy this up, okay? Because it looks a little bit messy. But what we know is minutes cannot be more than 60 minutes, all right? And so it means we need to convert this 95, okay, minutes into 1 degrees and 35 minutes because we know that 1 degrees, all right, is those seconds. All right. So I hope it makes a little bit of a sense because don't forget, let's write it here. Let's say NB, don't forget that 60 minutes, don't forget that 60 minutes, okay, which is 60 minutes is equal to 1 degree. It's equal to 1 degree. So it means when your minutes are more than, or the total more than, or the total more than 60, you must always convert that into degrees. All right. So now let me teach you how to convert that. So 95 degrees, then all right, it's like so we'll say, well, 95, if you say 95 minus 60, you will remain with 35. So it means you need to convert, ne? So it means for the first 60 minutes, it's equal to 1 degrees. So you'll say 1 degrees, and then how much are we left with? Because we said 95 minus 60. So 95 minus 60, you must have guessed it right. It's 35. So it means we are left with 35 minutes. So 95 can be rewritten as that. All right? 95 can be rewritten as that. Don't forget that in South Africa, following South African rule, you can add or subtract if only the annual change is moving in the same direction as the original magnetic declination. That is to say, west, all right, and then changing towards the west, and then you add the change. But if the annual change is moving in the opposite direction as the magnetic declination, that is to say, west, but changing to the east, then you subtract the change. All right. I hope it makes sense. Now, we're still finishing that, and then you will say, all right, now you will say, you would now say, therefore, you are having, 20, sorry, you are having 23 degrees. What's happening? 23 degrees, 95 minutes, and then you take this value and say 1 degrees, 1 degrees, 35 minutes, and then add your things. All right, 23 plus 1, it will give us of 24 degrees. 95 plus 95 plus, no, not 95, 35, I mean to say. All right, 30, where was I? No, 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 sorry about that. Sorry about that. Um, Sorry about that, because this one we already, sorry about that. This one we already, let me just cancel this one and take it here. All right, this one, 23 point, sorry about that, 23 degrees and 95, not 95, you see, not 95, but 23 degrees, 30, yo, yo, what happened? Yo, I canceled it. Sorry about that. Sorry about that, but it's fine. Um, Remember, for the first step, we said 2009 minus 2002, 2002, and we got 7 years. Sorry about that. And then we set our the total distance that magnetic north has moved was 6 minutes per year, was 6 minutes per year. All right, multiply by 7 years, and then we got 42 degrees westward. And then we also got that we have 53 degrees west, and then we add that with 0 degrees, 42, whatever, and then we got 23 degrees, 95, 95. All right, we got that. So yes, sorry about that. Then we said that because minutes cannot be more than 60 minutes, we need to convert. We need to convert that 95 minutes, that 95 minutes into 1 degrees, and 35 minutes. Then now you will say, well, you're having 23 degrees, 95 minutes plus 1 degrees, because now this value can be written as 95 can be written as that. So it means one of these degrees plus 23 of these, it will mean it's 24 degrees. But we know that this will remain with 35 minutes. So this will be our final answer, westward. All right, westward. So what about that? My things were cancelled. Which yeah, I'm sorry about that. And then we also have got this one. And we also have got this one here. We are having magnetic or mean magnetic declination of 23 degrees 33 minutes west of true north in July 2002. Mean annual change is 6 westward. So the only thing that changed now is this from the previous one. Remember, from the previous one we had 23 0.53. Now we have 23.33. But you'll agree with me that the analogy will still be the same. So no, now you understand, you got the gist of that. So the difference, in years, so you must have the difference in years. So these what I remember they want for 2011. So you'll say, well, 2011 it's like 2025 if they wanted to for 2025, which we started with, minus 2002, all right, which is approximately 9 years. All right, 9 years. And then that was for the difference in years. And then for we can calculate the total change. We can calculate the total change, or the degrees over amount of years. So you'll say, well, we've got that 6 minutes westward per year. All right, per year we multiply by 7 years. Not 7 but 9 years, sorry, multiply by 9 years. And then 9 times 6, you will get 9 years, you will get 54 minutes west. All right, you'll get 54 minutes west or westward. Now number 3, we can calculate the magnetic declination now for 2011. So you need the magnetic, let me just write MD for 2011. How do we go about that? Then we will say magnetic declination for 2011. So for 2011, it will equal to the 23. Now we start again. 23 minutes or degrees. Sorry, what's happening with this? Okay. We will have 23 degrees and then 33 minutes. All right, and then because it's westward, we are adding. So you'll say it's like 0 minute or 0 degrees 54 minutes. And then you'll say 23 plus this, it will give us 23 degrees, and then 33 plus 54, 33 plus 54 is 87 minutes westward. Then, or you can just say towards the west. So you'll say, therefore, our magnetic declination, therefore, our magnetic declination in 2011 was 23 oh, sorry. Remember, minutes cannot be greater than 87. All right. Okay, cannot be greater than 60. So we need to break down this first. All right, let's break it down here. Then what do we do? or we'll say 87 minus 60, then we 87 minus 60 is 27, so we know we have got one degrees. I don't know what's going on with this. 1 degrees and then 27 um, minutes. Sorry about that. Minutes. So that is this 87. So then we still 1 minute from this and add it to that. All right. So then it means our magnetic declination in 2011 was 24 degrees 27 minutes. So please don't forget this trick of stealing a minute and then put it there. All right. So ladies and gentlemen, I hope you are following on how we are calculating the magnetic declination. It's just simple, just need the understanding. And then we also have got the a magnetic bearing. So magnetic bearing. So we say the bearing is the precise direction from one point to another. We can say from point A to point B. All right, measured as an angle. So because your compass points towards the magnetic north, but your map is drawn using the true north, or you must calculate the magnetic bearing to navigate correctly. So three steps of calculating the bearing. All right. All right, so you must first calculate what you call the true bearing. So the true bearing is the angle measured clockwise. Clockwise, all right, is the angle measured clockwise from the true north, all right, to the line connecting from the true north, which is the vertical grid line on your map, to the line connecting the 2 points. All right, from the line connection the 2 points, and you must use the 360 protractor. You know, protractor is that now has I think 0 here. All right, like that. So procedure, you draw a line from point A to point B. So let's say this is point A, this is my point B, and then you draw a line from that to from there to there. All right, and then now what you do, you draw a true north line, a straight vertical line starting at point A. So you can say, if this is my point A, all right, then you say this is my true north, for example. All right, and then place the protector center on the point A, aligning the 0 degrees or 360 mark with the true north. So you can take that. I'm not doing that to scale. All right, that this will be your protector. All right, this will be your protector, and then read the angle clockwise to read the angle clockwise to the line AB. All right, then now and then now you'd read that from there to there. All right, I didn't place it, but this was gonna be must be placed here. For example, sorry, let me place it nicely here. All right, you're gonna place it nicely here like that. All right, like that. And then now you read the angle from the true north all the way to line AB. So this will be your true bearing. This will be your true bearing. All right, now where in your true bearing can be expressed as a three-digit number. 045 degrees, 180 degrees, 315 degrees is your true bearing. Now the step number 2, you calculate the current magnetic declination. This is what we have learned previously. All right, where in the first step you are calculating the difference in year and get the change. Take that change, multiply by the that change. All right, and then or to get the total change, and then that total change, it will give us or you will be able to calculate the magnetic declination today. All right, or whatever year you were given. Then now you're done with that, and then now you convert your true bearing to magnetic bearing. right? This is the most crucial step for the navigation. You must adjust your true bearing from the map so that the real world compass, which follows the magnetic north, can use it. So the key is to remember the spatial relationship between the true north and the magnetic north. So in the Southern Africa context, the magnetic north is always or is almost always west of the true north. All right. So so if the magnetic declination is west of the true north, you add the magnetic declination to the true bearing. So this is your true bearing, and then you add magnetic declination. But if it says east of the true north, you subtract the magnetic declination from the true north. All right. From the not true north, but the true bearing. All right. That is that. All right. That is the secret that I want to bring to your attention. Now, we just want to we just want to understand this part, and I think we can call it a beautiful day, whatever. All right. And so we assume that our true bearing, we assume that our true bearing is 125 degrees, and then your calculated magnetic declination for that given year is 24. That's what we calculated, 24 degrees 35 minutes west. All right. And then, but now, since the magnetic declination is west, it means you must add it to the true bearing. So you'd say, well, um, um, magnetic, you'll say magnetic bearing, can abbreviate it as MB. All right, magnetic bearing, it must be my true bearing, because it's westward. You add magnetic declination. All right, I'm just giving you the gist of this. All right, and then now you say, well, we were given that um, our true bearing is 125 degrees, and then we don't have any minutes, okay? And then plus 24 degrees 35 minutes, all right? And then now you'll agree with me that this is the same as you say 125 degrees 00 minutes plus um you know um the 24 plus 24 degrees and then 35 minutes. All right, so this will just give us 35 minutes, and then 125, let's say 125 plus 24, and it gives me 149 minutes. So you'll say it's 149 minutes. All right, then now this would be your magnetic bearing. So the magnetic bearing you would use with your compass to walk from point A to point B. It will be 149 degrees 35 minutes. Ladies and gentlemen, this brings us to the end of our lesson on the magnetic declination and magnetic bearing. I hope you enjoyed this lesson. Please comment on the comment section, tell us how you feel about this session, and please communicate with us the other things that we can cover on this section of the map work. So enjoy this one, and let's keep rolling. And you know what I'm about to say. Until next time, cheers.